Okay, for our 10-6 summary, we're going to talk about when we have chords that intersect in a circle. So if I have two chords that intersect, remember chords are the ones that stay inside the circle and the ends are on the circle. If I call this A and this B, this C and this D, we multiply A times B because it's the part of the chord times the part of the chord. Okay, so this was part times part and part times part. The chord is split into two pieces. So for example, if I said that this is 3, this is X, this is 6, and this is 8, I would say 3 times 8 is equal to X times 6. So 24 is equal to 6X. So X is equal to 4. Okay, if we have a tangent or a secant, okay, so remember the difference. Tangent is on the outside and it only touches the circle at one point. Secant goes through the circle. It's on the inside and the outside, and it would touch the circle at 2 points. The external part is the outside part. Okay, so for a tangent, the whole thing is external. For a secant, just the part on the outside is the external. So tangents and secants on the top of the next page, tangents and secants, we do the same thing, right? So if I have two secants, I do the external part. Let me get another color. The external part times the whole thing. Okay, and then we would do this external part times the whole thing. Okay, so it goes external times whole. So for example, if this part was 10 and this part was 8, and let's say this part was 12 and this was our X, we would say outside, the external times the whole thing, because 10 plus 8 makes 18, is equal to the outside times the whole thing. So I have to add the two pieces together. So over here I'm going to have 180 is equal to 144 plus 12x. So then I'm going to have to subtract the 144 from both sides, and I get 36 is equal to 12x, and then divide and get x is 3. Now clearly I didn't draw that very well, but x is 3. When we have secants, we do the same, when we have tangents, let me redraw this. If we have a secant and we have a tangent, we still do the external times the whole thing for the secant, and then for the tangent, it's also the external times the whole thing. It's just that external and whole are the same for the tangent. So it's still the same formula, but it's just that the tangent's the same number twice. Okay, so if this is my problem and this is the X, and here I have 8 and let's say this is 6. So external times the whole thing, 8 and 6 make 14, and then external times the whole thing. When I multiply x times x, that becomes x squared. And then 8 times 14 is 112. To solve, if you need to unsquare something, that's the square root. So I take the square root of 112, and this one's going to be a decimal, 10.58 if I round it. Okay. Alright, so let's look at the practice questions. Find the value of x. These are two chords. The chords split each other up right here. So that means I'm splitting it into two pieces. So it's 4 times 9 and x times x. So 4 times 9 is 36. X times x is x squared. And I'm going to solve by taking the square root. Number 2, the outside times the whole thing is equal to the outside times the whole thing. So on this problem, I have 100 on the left. On the right side, I can combine my like terms on the inside first. I get 4x. And then I'm going to have 4x squared. I can divide both sides by 4. I get 25 is equal to x squared. And then take the square root and I get x is 5. Number 4, there's a tangent and a secant. So tangent is outside times whole. Secant is outside times whole. So I've got 81 is equal to, I can put these together and that makes 3x. X times 3x is 3x squared. I can divide by 3 and I get 27. So then x is the square root of 27. And that's going to be a decimal we're going to have to round. So 5.2. Number 5, find the radius. So the radius is here. It's a tangent and a secant. So tangent is 12 times 12 because outside times whole. Secant is 6 times the whole thing. So the whole thing would be 6 plus r plus r. Okay, if I simplify this, I've got 144. On the inside here, I have 6 plus 2r. r plus r is 2r. And then I can distribute this 6 from the outside. And then I can subtract 36. And then I can divide by 12. I don't know why I skipped number 3. I guess because it was outside the box. Let's go back and do number 3. 36 is on the outside. It's a tangent. So 36 times 36. And then 24 times 24 plus x. So 36 times 36 is 1296. 24 times 24 and 24x. Subtract the 576 from both sides and divide by 24. Alright, number 6, we've got two chords. Chords split each other into pieces right here. So we do the two pieces of one chord, 7 times 8, and the two pieces of the other chord. So we've got 56 is equal to 10x, and 5.6 is equal to x. Number 7. Outside is 8. The whole thing is x plus 3 plus 8. Outside is 10. The whole thing is 10 plus x minus 3. So I'm going to have to simplify a little bit. And here I have 10 times inside would be 7 plus x. And now I can distribute. 8x plus 88 is equal to 70 plus 10x. And then I'm going to have to move my x's to one side and my constants to the other side. So I'm just going to move this work up here. If I move this 8x over, I'm subtracting the 8x from both sides. So it's going to be 88 is equal to 70 plus 2x. Move the 70 over, and it's going to be 18 is equal to 2x. So x is equal to 9. Number 8. Outside is 4. The whole thing is 4 plus 2x. Outside is 3. The whole thing is 3 plus 3x plus 1. So over here I can distribute. Over here I want to simplify a little bit first and put together my like terms and then distribute. So I'm just going to leave the left side alone. And now I'm going to move my x's over by subtracting the 8x. And then I'm going to move the 12 over. And I get 4 is x. Alright, then the last one, part times part. And 28 times, and I ran out of space, x plus 5. So when I multiply, I'm going to have 42x is equal to, and this is going to be 28x plus 140. I'm going to subtract the 28x and then divide by 14. Okay, so that's all of 10.6 practice. I'm going to stop the video there and then